Yes. Hi, dear students. Welcome back to my session. In our previous session, we had discussion about the star to delta transformation technique, and we solved. Uh, we derived the derivation of that, and we solved a few problems on the star to delta, how we can convert into the star to delta. On that class, we had a discussion about the deeply about the how we are going to be convert star to delta and how to draw the star circuit and we used tactics how to remember those formulas and we wrote those formulas in theoretical way of form. So that's it in our previous class. So in this class we are going to be discuss some related problems which are based on by using the basic laws of electric circuits, right? So problems on basic laws of electric circuits. So we will see random problems. We will it will combination of all the laws. I can say KCL, Kirchhoff's current law, Kirchhoff's voltage law, and current division rule, voltage division rule, rules, laws, and conversions means star to delta transformation, delta to star transformation, and also mesh analysis, nodal analysis. This is a combination of all those. Let me write those things here. Till now we saw we had discussion about the mm, techniques, that is CDR, current division rule, and VDR, voltage division. Next, we used KCL and KVL. Based on the KCL KVL, we apply the mesh analysis and nodal analysis. After that, we did the transformation star delta to star. First transformation is delta to star. Next transformation is star to delta. Before CDR, VDR, you should know about the series and parallel, right? Series and parallel. So this all the laws and rules conversions we already discussed. Now based on this analysis, based on these rules, based on these laws, we're going to be applied these laws in various circuits. Now let's see. Go for the next slide. So here let me review series and parallel resistors. These are the, as you know, these are the series resistors. R is equals to R1 plus R2 plus R3. This is series resistor. This is a parallel. Why this is series? Why in parallel? Because here the current is common, right? If you observe this current is common. Yes, I'm in this session. I want you guys are going to be brushing up your knowledge. That's it. I want to combine the all the concepts in this session. If this session is not enough for you guys, I will take next session also based on the this applications. I am discussing only application, how those laws is going to be applying the various circuits. So when the current is common for the entire circuit is nothing but a series. When current is dividing means the I is entering here is divided to the I1, again further divided to the I2, further is going to be divided to I3, I1 is going to be I is going to be divided I1 plus I2 plus I3. That is the reason this is parallel. So let me discuss one of the MCQ. You should answer these types of MCQs with the current I flows I shown, which is the higher potential at point B or point C. Which one is higher potential? Point B or higher potential? Point C or higher potential? When current is moving. Current is, as you know, the current always moves from the higher potential to lower potential, right? As you know, current always move from the higher potential to the lower potential, as you know. So let me discuss in brief, right? So let's see, this is a solution. With the current I flowing, I shown which is figure high potential, point B or C. The solution is current flows from the high to low potential, just like water flows downhill. So I am going to redraw the circuit like this. If I given the battery like this, plus and minus, if a resistor is connected like the same value of resistance, let me take the value of resistor is C over here and B over here, right? Now as soon as you switching on the supply, this is a positive sign, this is negative sign, immediately the current will flows. Means, now tell me which is the higher potential and which is the lower potential. Obviously the plus C is higher potential, minus B is the lower potential. Why? Always move from the higher potential to the lower potential. Current always move from the higher potential to the lower. Wherever the downfall is there, right? If this is a hill, wherever the downfall is there, that will always roll to the downfall only. Always current will flow higher potential to lower. Now the higher potential is C. The answer is C is higher potential and B is the lower. If any circuit is given like this, you should redraw by connecting the voltage source across the circuit. Then you will get an idea about the circuit clearly. If circuit is not given a voltage source, you should draw it by arranging the voltage source. Then you will get an idea how the current will flow. If you given the voltage source across any current flowing path, then you may assume positive and negative signs. Then you will get a clarity how the current direction, how where is the point is higher potential, which one is lower potential. Then you can get to know about the value of high and low potentials. So next, see one more problem. In this problem, now I want you guys should know which rule is we can apply like these types of problems. We have bunch of rules, right? Like these rules. Let me look after our rules. We have bunch of rules like this. We have 2, 3, 4, 5, 6, 7, 8 types of rules. Then 11, 12 types of rules, laws, and techniques are there. Which technique is can be feasible, can be applicable for these types of circuit? By looking this circuit, just if any circuit is given on your examination, first look at the circuit. First look at the wait. First look at the circuit, then start analyzing, then just write some basic points, then start working on that, right? So now this is the given data. Now put this given data in the circuit. Then what he wants to know, find the equivalent resistance of the network. What is the equivalent? What does it mean of equivalent resistance? Means if there is a bunch of resistances are there, you need to be convert those bunch of resistor into the single resistor. That is called equivalent resistance. Equivalent resistance means total resistance on the circuit. What does it mean? Equivalent means total resistance of the circuit. The simple definition of equivalent resistance of the network means total resistance of the any circuit is called equivalent resistance. Now for the total resistance of the circuit, how you can measure it? How here there are R1, R2, R3, R4. There are 4 types of resistance, 4 different values of resistance are there. Then how we are going to be measure these 4 types of resistance? Which laws are suitable among the 12 laws or rules or techniques? So for that you need to be look at the circuit first. Then start think which law, which rule, which technique can be feasible for this problem, right? Now let me put this all values into the circuit, right? Right. I kept all the values. This is R1, R2, R3, R4. So whatever the values of R1, we will R1 is nothing but a 100, R2 is nothing but a 50, R3 is a 50, R4 is a 75. So these are the values he given. Based on the looking of the circuit, if you I can redraw the circuit like this, right? I'm going to be redraw the circuit like this. So I'm going to be redraw like this. I'm going to be draw only resistances. This is R1, this is R2, this is R3, and this one is R4. Simple I did. This diagonal of R4 I connected into the state. I just shifted this point to this. Is there any different by shifting of this point? Is there any value is going to be changed? No, right? For the making of this point and this point, that doesn't make a changing of any value. Same value. Then I shifted this to here. Just of this diagonal of this R4, I am making to this straight. Then I can pictorially I can assume these three are parallel. If the diagonal is like there, like this, the basic under if some students have the mm, uh, basic knowledge about the electric circuits, those students have some little bit confused about the R4. So for that reason I shifted that R4 into the straight wave form. Then we can think, we can look at the problem directly. Those R2, R4, R3 are parallel. By looking at, you can say it, right? Then this R2, R3, R4 are, I can name it as a R2, 3, 4 are parallel. Now I am going to be do parallel equations. Parallel law. What is parallel law? 1 by R234 is equals to 1 by R2, 1 by R4, 1 by R3. This is parallel law, right? Then I can get 1 by R2, 1 by R3 plus 1 by R4 is equals to R2 is nothing but a 50, R3 is nothing but a 50. 2 and 3 values are both are same, right? 2 and 3 values are both are same. R4 value is 75. By doing the mathematical algebra, then you will get 16 by 300 is nothing but a, when I shifted denominator into the numerator, R234 is nothing but a 300 by 16. 300 by 16 is nothing but a 1619 ja 300. Then it will be value is R234 value is 90. The result of R234, which is parallel to the R1, right? Just observe the circuit again. The result of R234, this R234, so the result of R234, which is series with the R1. So I'm going to be redraw the circuit again. This is R1, this is R2, 3, 4. This is R1. Then it will be, now you need to apply which rule among the 12 rules? Simply series rule, right? R1, which is series with the R2. Then you need to be add these two values of resistance. That is R1 plus R2, 100 plus 19. Hence my value is 119. My value will be 119 ohms, right? Now my current will be, find the current in each resistor, right? Next you want to know the, first A is done, the equivalent resistance of the circuit is. Now let me draw the equivalent circuit diagram after finishing of this. I'm going to be draw this equivalent circuit diagram. Let me erase this all the marks on the screen. Now I am going to be draw the equivalent resistance of the network circuit diagram. How this is going to be? This is value of this is battery. What is the value of this R1234? The value is 119 ohms. What is the value of this battery? 6 volts. Just 6 volts. This is equivalent circuit of, this is the flowing of current through this branch. If he asks how much current is drawing the entire network, you need to be find this value. Even though this is value is required for the further solving of B problem, this value is required. Then I'm going to be find this value also. I is nothing but a V by R. B is nothing but a 6 by R equivalent. 6 by R equivalent is nothing but a, let me do on calculation. 6 by 119. Then value will be 50 milliamperes. 0.0, value will be 0.0504. So it's nothing but 0.0504. 0.0504 is nothing but a 50 into 10 into 10 to the power of minus 3 is nothing but you can say 50 milliamps. So this is the value of I. This value I1 value will be 50 milliamps. Now he wants to know the current in each branch, right? He wants to know the current in each branch means I2, I3 and I4. He wants to know the current in each branch. For that, let me move to the next slide. Here, if look at the circuit carefully, you will get in one important point. From here, hope you got the one important point. What point you are getting? Here the voltage, which is common for these three resistors, right? How I can say? Because these three resistors are parallel. Parallel means the voltage is common. If the series means current is common. So since these three resistors are same, then I can find the voltage across one of the resistance means those value of voltage will be same for the rest of the resistors, right? For that, I'm going to be find the voltage for this. Simple. I'm going to be redraw the circuit for you guys. Right. Now, what he wants to know, find the current in each resistor, means how much value of current in R1, R2, R3, and R4. So he wants to know the current in each branch. So for that, you can go for which types of technique? For that, I can go for, is that nodal analysis is better, right? Is the nodal analysis better? No, right? Here the node is common for these three resistors. The nodal is not good. The mesh analysis is that better. For this, I need to apply one, two, three. I need to apply three meshes. Lengthy process. Then is that comes under the star or delta category? No, right? So there is only one way we can solve this problem in only in series and parallel mode only. For that, you need to be clarity about the which types of technique we are going to be applying. So that is the reason I used to say about the 12 rules, 12 techniques, 12 laws, one of the 12 laws. So those 12 techniques, rules, and laws are very important for the solving of any type of any types of equation, any types of networks. For this, I'm going to be finding current in each branch. For that, I know the current of this resistor. How much value of current? Just now we got in previous slide, 50 milliamps, right? 50 milliamps. So now this is current is going to be divided for this three. If I know the value of voltage for this three value of resistors, then I can able to find the current easily, right? If I know the value of voltage of this three resistors, if I know the value of voltage and resistor, then I can able to find the current easily. Is nothing but I is equals to V by R. Same I'm going to apply. Now the voltage among these three resistors are same. That voltage is nothing but a V. This voltage, this red indicated line, this voltage is same of these three resistors. Then I am going to be find the voltage across these three resistors is nothing but a V is equals to I into R234, and this is the equivalent resistance. Already you get it. 234 is nothing but a 234, 3 are parallel. Then you will get one resistance in parallel mode. That is nothing but a R234. R234 already you got 19. If I do multiply with 99.050, then I can get 0.95 volts across this three value of resistors. Then it will become a 0.95. Among the each resistors, I will have 0.95 value of voltage. 0.95, 0.95, 0.9. Now I can find the current easily for this path, and for this path. So for this path of current, I is equals to, I know the voltage 0.95 and I know the resistance 50. Then I can easily find the current. I2 is equals to V by R2. I3 is equals to V by R3. I4 is equals to V by R4. Then I can find the total current of this, sorry, individual branch currents of the circuit. Now I know the currents of I2, I3, and 4. Let me check is my answers are correct or wrong. If I do add of this 19, 19 and plus 12, I must get 50 milliamp, because as per the law of KCL, current entering at a node is equals to current leaving from that node. Current entering at a node is equals to current leaving from the node. Sir, and you may get a doubt. Sir, shall we apply current division rule, sir, or voltage division rule, sir? You can apply. You can apply anything. For this, you can apply current division rule also. Current division rule, how you can apply? And you know this total current 0.5, and you are going to be find this value of resistance, means opposite value of this resistor and total value of resistance, like this. So you can do from your side. If you will get exact values, but those processes very lengthy compared to this process. All other processes are very lengthy. That is the reason you choose the best best technique for the proper solution, right? This is a problem number 2. In this problem number 2, we are going to be calculate the current through the galvanometer in a Wheatstone bridge, like this. This is the galvanometer, right? One moment. In this problem, we are going to be find the current through the galvanometer. Right? This is the galvanometer. The problem he given itself like this only. The directions is doesn't matter for you guys. If in this problem itself, if he given the direction, that is doesn't matter for you guys. You should never confuse about the given directions. You should follow your rules only. For uh, this types of circuit, which is the best method for you guys? Which is the best method for the better solution, for the fast solution, for the quick solution? You can follow a lot of methods for the circuit. You can follow the mesh analysis, means loop analysis technique, and I can say a loop equation based on the branch currents, or I can say loop equation based on the loop currents, right? For that and you can apply star and delta principles. Is there any series and parallel can be applicable for this? We can't apply series and parallel, right? For this, see, because here there is no series, there is no parallel. If you look at this, if you see these types of circuits like this, here there is a resistance is there inbuilt, there is a value of resistor here. He given 40 ohms, means there is a value of resistor is there in this diagonal element. So there is 40 ohms is there, 10 ohms and 20 ohms. Is this not series, not parallel? So it means it's not series, not parallel, means it's a delta, one delta. I can convert this delta into the star like this. So this star, again it is going to be series over here, again it's going to be series over here. Then this both series R is going to be parallel. Then hence the given circuit is going to be parallel, and this is parallel is going to be comes which is series with the this star element. Then both are series go into the summation manner, and hence we will get only equivalent value of resistance in the network. Those equivalent value of resistance, if I divided the voltage with the equivalent value of resistance, then I will get current through this element. If I know the current based on the current division rule, or based on the some other division rules, you can find the branch currents. So there is a lengthy process if you apply the star delta also. Then is there any other way of techniques? I can go for little bit the loop equation is better for me, right? For other techniques it will be very lengthy. If I go for the loop equation, I can get easily in the common branch currents, right? Now that is the reason I am applying the KVL to mesh. No, I'm applying the KVL for this mesh. Let me remove all the marks. So how can I apply the mesh? Let me draw this for you guys. Right. So here, for this PPT, I took it from other side. So in this, he followed only based on the directions he's given, x, y, z, and this is nothing but x minus z. This is nothing but y plus z. So like this, he is following. The outer terminal is nothing. This is nothing but x plus y current. So like that, he wrote. Now on that analysis only, I'm going to be writing. Now apply KVL to mesh. Mesh here A D C A D C E A. This is the one loop. Clockwise. This is the one more loop. This is one more loop. For this loop, for this, he followed the living sign. Sorry, starting sign. Plus minus. So -2. Sorry, living sign for this same thing. Sorry, let me remove this. Right here. In this, he is applying the KVL for this A, D, C, E, and A. while applying this KVL, I used to start from the battery. From the battery, the leaving sign is positive 2, and for this the leaving sign is minus 20, and the branch current is what is the branch current? This is a loop equation based on the branch currents, not loop currents. Wherever the branch currents is there, I'm going to be write those branch currents values only. Again, I'm going to be clear. I'm going to be repeat the same point. This is loop equation based on the branch currents, not the loop currents, right? So that is the reason I'm going to be write only branch currents words. Here my leaving sign is negative 20, and my branch current is minus 20. And my here my leaving sign again based on this positive and negative. Let me clear about this point. First, as soon as I followed this, right. As soon as I followed this, first you guys need to be know the signs. Here there are these loops 1, 2, and 3. You need to be follow clockwise 3 loops. This is 1, 2, and 3. For this, next your second step is you need to be give the signs plus and minus based on the branch currents path, plus and minus. For this is a 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 plus and minus, right? For this positive and negative, for this, right? And this is already sign is given by in question itself only. Now your job need to be find the draw the write the loop equation for this loop one. This loop one is nothing but a. So let me change this marker, then you can easily identify the marks. Let me add green, is better to represent easily. So a, next D, C, E, and A. This is one loop. Always I used to follow I used to start from the battery or independent branch. So here this is battery. From this I'm writing the leaving sign plus 2, and from here my leaving sign is minus 20, and my current of this branch is Y. Then for this my leaving sign is minus 15, and the current flowing through the particular branch is X plus Z. As you understand why the X plus Z is comes to the picture is equals to 0. Hope you know how the X plus Z is comes. Let me clear here. X plus Z is given itself. How the X plus is comes? Because from here, sorry, Y plus Z. From here Y is comes. From here Z is comes. Then Y is nothing but a Y. The current entering at a node should be equal to the current leaving from the node. Based on this directions only, I am following the writing of the equation. So for this, the current leaving from this branch is equal to current entering from that node also. So then the node is D. The current entering to the node is nothing but a Y plus Z. It should be equal to the leaving from that node also. Then it will be Y plus Z. From here also, if the current enters here and the current leaves from here, current leaves from here also. This is entering point of B. So this is X. Let me write. This is X is entering at a point of B, and this X current is going to be living in the two ways. One way already you denoted, right? Z. The rest of the way, how you are denoting this value? It is nothing but a the supplying of current minus already delivered current is equal to rest of current is nothing but X minus Z. That's way of procedure to the identify the nodes. Here he is assumed only three currents, x, y, z. He is not assumed x, mm, w, x, y, z. He is not assumed like four currents, because here only three loops, one, two, three. That is the reason he should assume only three currents itself only. If he is not added the w for this, he is used only given currents x, y, z. Those currents only he utilized for the naming of this 30 ohms branch and 15 ohms branch. By using those x, y, z parameters, he given the naming of the 30 ohms only, 30 ohms and 15 ohms. So like that, you should very clear about the assumption of your currents, means unknown value of currents. Then only you will get then only you can write the loop equation clearly. After writing the loop equation, then you can solve the algebra. Then only you will get the correct answers. Otherwise you will get wrong answers, right? Hope you clear about the identification of this x minus z and y plus z. So let me move through this. So this is y plus z, right? This is not x plus z, right? This is y from here. This is always y plus. This is not x plus z. Let me write this y plus z. So that is comes to here minus 20y and plus 2 and minus 15. Hope you clear. So this is way of writing the loop equation for the first loop. Now let me move to the next loop. Where is the next loop? After doing algebra is nothing but a minus 15 minus 20y is nothing but 35y minus 15. Let me add pointer, right? Minus 15, sorry, minus 15 minus 20 is nothing but 35y. Minus 15 into z is nothing but a minus 15z plus 2. Then this minus terms I'm going to be converted in shifted to the right side, then it will become a plus. This is the equation number 3, right? Should be equation number 1. It's not equation. This should be equation number 1. Next, multiply equation number 2 by, where is equation number 2? One moment. Wait, one slide is missing. Moment. I need to write two more equations. One moment, please. So let me see the equation number 1 and 2 also. This is equation number 3. I wrote while considering the A, D, C, E, A. Then let me write the equation number 1 also. From the equation number 1, I can take this loop number 2. Right, sorry. For this loop number 2, I'm going to be right. Please check it here. For this loop, for this, from I'm going to be again add the signs positive and negative. So for this, I am adding the signs positive and negative signs. For this also positive and negative signs are there, and based on the current direction, positive and negative signs is there. From here, instead of galvanometer, it should be add the inbuilt value of resistance, that is 40 ohms. For this, I need to be add positive and negative sign. For this, positive and negative sign. So here I'm going to be apply the KVL to the mesh ABDA. This is simple. A, B, D, and A. For this, just now you wrote this is loop 2, right? You can loop 2. You can write the equation of loop 2. I used to follow the leaving sign minus 10, leaving sign with the value of branch current. Branch current here I assumed as x minus 10x, and my leaving sign for this I used to follow always independent branch. Independent branch here the 10 ohms I used to start from the independent branch only, then you will get a good clarity about while the writing of equation. Otherwise, if you follow the dependent branch, this 40 ohms is dependent for this two loops, this 20 ohms is dependent on this two loops currents. So this is completely independent. If you're writing by using the independent branch currency, you will get a little bit clarity about the of your equation. So you used to follow always currents always start from the independent branch currents. So based on this, minus 10 10x minus 40 y 40 z not y z, and this is plus the living sign is plus 20y. This is the equation. Then I took as a common of 10, then it will become as minus x plus 2y minus 4j. This is equation number 1. I took it as a common of 10. 10 is nothing but a minus x minus 4 plus 2 z. So I took it as a common of 10. It should be like this x y z information of ABC, like that formation. It's formation like x y z. Then I'm going to apply this is the equation number 1. I'm going to apply the KVL for the equation of BCDB. This is B C D B. For this, again you need to follow the independent branch. From the independent branch, this is the loop currents clockwise. Living sign is minus 30 and x minus z, and the living sign is plus 15, and the current is y plus z. This is not x, this is y plus z, and my living sign is positive 40z. Then it will be minus 6x plus 3y plus 17z. Then the equation will be 2. What is the equation? Equation will be 2, and these are the two equations you need to be remembered clearly. You need to be right clearly. This is equation 1, equation 2. Hence, but this is loop 2 and loop 3 equation, and already you wrote the loop 1 equation. Get the loop 1 equation. By doing some algebra about the loop 1 and loop 2, loop 3, then multiply the equation 2 by 6 and subtract the equation 2 from equation 1. If I do multiply with equation 2 with 6, means where is equation 2? This, right? This is equation 2. Equation 2 is nothing but minus 6x plus 3y plus 17z. We can get, after solving those three, multiply with 2 by 6 and subtract equation 2 from equation 1. Means if we do multiply equation 2 by 6 means 6x by 6, subtract equation 2 from equation 1. Simple, what I want to say, solve these two equations. Means equation 1 with 6x, not 2, equation 1. You should write equation 1, multiply equation 1 by 2 and subtracts equation 1 from equation 1 from equation 2. Then you will get 9y minus 14j. After getting this, multiply equation 3 by 9, then equation 4 by 35, then you will get like this independent value of current, means z value you will get it. Directly you will get z value. From this z value means directly you got the exact current which is flowing through your galvanometer. This value of current you got it right directly. You solve in this way of procedure, you will get the values directly. Whatever we discuss those, so after getting of equations 1 2 3, that is all related to your mathematical. You can solve based on your comfort and based on your way of expressions. You can solve, use techniques. There are a lot of, there is a lot of techniques for the solving of any number of equations, but there is no proper procedure for the solving those equations. You can use any technique as per your mathematical rules, but those is not comes under this procedure. The procedure comes ends up to the writing of this equation 1 2 3. It's done from the electric circuit side. After the writing the three equations, your mathematical knowledge comes to the picture. By using those mathematical funda, you need to be solve the unknown parameters like x y z. But here while you solving is directly you are getting z value, means you are getting the current flowing through the galvanometer. So that's reason you know no need to solve the branch currents of x and x y and x minus z plus x minus z and y plus z, those values are not required because the examiner asked only current flowing through the galvanometer. Based on that, you need to be answered, right? So that's it. This is about the solution for this problem. Hope you guys clear about the solution. This is very important problem and most repeated problem also. This one is most repeated problem on your examination point of view. Sometimes here they used to give some value of resistor, or instead of giving the value of resistance, they used to mention 2 voltage comma zero point 0.5 ohms, like this. They will mention, means the internal value of resistance of this battery, like this. So for while he giving like this, you need to be showing this value of resistance by representing this zero point 0.5 ohms in external side. Then you can write the equation very clearly while you are writing the loop equation. So sometimes he will give the inbuilt battery resistance, or sometimes he will give the external value of resistance, which is series with the battery, like that. So please try to observe the circuit at least 1 minute, then start the indicating the direction of currents, and indicate the signs, and indicate the branch currents, and last indicate the loop currents, sorry, not loops, direction of the loops. So that's the way of procedure to solve the bridge circuit. This is called, comes under the category of bridge. Means on your next semester you will have the subject like electrical electronics measuring instruments. On the subjects there are a lot of bridges: Kelvin double bridge, sharing bridge, Wheatstone bridge, like those bridges are there. So on those bridges you need to be find the currents. If you understand here only, then you can solve the problem on the EMA problem and the EMA subject. So that is the reason the subject is interlinked with the all other subjects. So try to focus here. Next. So next problem number 3. In this problem, he want to know the current. He want to know the current. For that, R2 is equals to 2 ohms, and R3 is equals to 3 ohms. I2 is equals to 6 amps. I3 value how much? Tell me how much. Calculate the IT. Suppose single digit term, means he given like, let me put those values. He given the I3 value, means this value. Sorry, I2 value he given, means 6 ohms. This is 6 amps. You given the R1. Is he given R1? No, right. R1 is isn't given. R2 and R3, 2 and 3. R2 how much? 2 ohms, 2 amps. 2 ohms, R2 2 ohms. Next R3. 3 how much? R3 how much? 3 ohms, right? Next he given I2. Now he want to know the I3 value. This is simple, right? For the flowing of value of current and the flowing of current and the given value of resistance, you can easily find the voltage of this resistor across this B and C nodes, right? That means if you know the value of voltage across this B and C, means B and C, which is completely parallel with the other element, is nothing but R3. Hope you clear, you guys. This R3 is completely parallel, right? This is parallel circuit across this B and C. If you know the value of B and C voltage, then it's indirectly the voltage is common for this R3 itself, and the R3 value is given by default on the circuit. Then if you know the value of voltage and the given value of R3, then you can measure the unknown value of I3. Hope you clear what I'm trying to say. So no need to be find the value of I1, no need to be find the value of E. These unknown parameters, leave it. But examiner and that person is want to know the I3 value itself only. For the finding of I3 value, you depend upon this circuit is enough. This B and C is enough. B and C, the value is given like this, 2 and 6. Now the value of what is the voltage across B and C? What is the voltage across B and C? It means B and C is nothing but a voltage across B and C. VBC is nothing but a I into R. I2 into R2. What is the value of I2? 6 is given, and R2 is 2. The value of BC is 12 volts. Right? He given 12 volts, means across this BC to 12 volts there is there. Same to 12 volts will be appear across R3 also, right? Because the voltage in parallel is same. Now you know the value of 12 volts and you know the value of R3. R3 value how much? 3. Then you can find the unknown value is nothing but a I3. I3 is nothing but a, as per the Ohm's law, V by R3. Here V is nothing but a 12. 12 by 3 is nothing but a 12 by 3 is 4 4 amps. 4 amps is flowing through this resistor. So that is value. This is the term. Answer is 4 amps. So this is the way of solving the problem based on your techniques. Among the 12 techniques, rules or laws, you should know which is rule perfect for the solving of any network. You should not do any, you can apply the mesh analysis, you can apply the nodal analysis. Is that suits to the circuit or not? That will comes to know, that will you will get to know by solving of many problems. Then you can decide which one is best and better method for the solving of any network. Some most of the times the examiner never give you need to be follow KVL, you need to be follow KCL. He will never give the proper method. He will give only circuit. He wants to know the current for the particular branch only. For that, you the only you the one person who can decide the suitable method for the circuit only. That only you are going to be decide. So this is a way of doing the problem. So he's given in the sliding mode clearly. Simple is given in some complicated way, but don't follow some other. If you not understand like this, you can follow my procedure. I'm following only BBC like this simple way of technique. So here the answer is 4 amps same. So this is the way of procedure for the solving of some unknown branch currents. Okay, hope you guys understand all the concepts and the how to solve the problems and the way of procedure. Hope you guys clear about these problems. Try to do more problems, and on the next class also we will do some more problems mm, on based on the 12 rules. We will do more practice on the problems only itself, because the problems are very important for this chapter DC circuits. On the next section there is theorems are there. Next on the next chapter there is the only theorems are there. We have only 6 theorems. Based on theorems we are going to be solve the circuits. For that also this basics is going to be utilized. So I want you guys need to be thorough about this knowledge. You need to be understand these 12 rules, these 12 concepts, rules, and these laws are very important for the solving of any branch currents or loop currents or particular current flowing through the any element or voltage across the any element. So you should very clear about the procedure, right? Thank you. We will meet again. Thanks for your time. Bye bye.